Good afternoon, everyone. I am Ella, and on behalf of Solar Quarter Middle East and the First View Group, it's my pleasure to welcome you to our upcoming masterclass webinar on next generation solar power inside the Huawei SUN2000-150K-MG0 Inverter. Before we begin, I would like to extend our sincere gratitude to Huawei for their pivotal role in making this event possible. Their dedication to advancing sustainable energy solutions is truly commendable. Today, we have the privilege of diving into cutting edge advancements in solar power technology with our esteemed speaker, Ms. Heba Sahabi, Solutions Manager, Digital Power Smart PV and ESS at Huawei. Mr. Habi will enlighten us on Huawei's Fusion Solar roadmap, upgraded features of the Huawei SUN2000-150K inverter, specifications and design requirements of the inverter, and deep dive into safety features of the inverter as well. Mr. Habi's expertise promises to provide valuable insights into how these innovations are shaping the future of solar energy solutions. So, without further delay, may I now invite Ms. Hiba Tahabi to commence this enlightening session. Over to you, ma'am.
First of all, Ahla, thank you so much for the introduction and for the humbling introduction, actually. And it's always a pleasure to be conducting these webinars with Solar Quarter and always for the amazing organization. So I'll give a bit of an introduction about myself, as Ahla also introduced me. I'm a regional solution manager with Huawei. So my background is in renewable energy engineering and electrical engineering as well. So my experience or area of expertise lies in PV solar systems along with energy source systems. Allow me to just share my screen and let me know, Ahla, when you can see it. Can you see it now?
Yes, I can see.
Okay, perfect. Let me just go in slideshow. Can you hold it, please? All right, so first of all, let me just take you through the content of the presentation today. We're going to go through a quick overview on the roadmap. So how did Huawei's products evolve in the past 10 years? And then, as you know, this webinar is going to be covering the 150 KTL inverter. So we're going to dig into the specifications of this inverter, and then what are the upgraded feature of this inverter in comparison to our previous inverters, and also the inverters available in the market. And we're going to end the presentation with a technical deep dive into the safety features of this inverter. So starting with a roadmap, for the past 10 years, Huawei has committed itself to innovation, digitization, and sustainability by also applying our expertise in ICT to drive innovative solutions and improve, let's say, the efficiency and reliability of these products. So we have entered the market in 2013, introducing the string inverters. And then in 2017, up until 2017, we have improved our product range while also introducing the smart PV management system. So through the smart PV management system, we have also incorporated AI and big data technology, of course, from our expertise. And then we allowed the clients to monitor on a real-time basis their components in the system, and also for the predictive maintenance, while as well controlling these components, let's say. Up until 2021, we have also increased our range of products, and we have also introduced the utility scale inverters, while as well improving these safety features and, let's say, compatibility features within other products that we have introduced to the market. Up until this year, or till this year, we have also introduced the smart energy source system that allows us to integrate storage with PV power generation in order to improve the efficiency and reliability of the solar PV systems, while also introducing the optimizers. So through AI Boost and optimizers, we also allow our clients to monitor and control the system up to the module level, while other products are also available from the DC chargers and the cloud services, and added features from when it comes to the grid support features, improving the compatibility to different or various grid standards worldwide. So this was just a quick, let's say, cap on what we have been doing since the past 10 years and so far with our products for the Fusion Solar division within Huawei. So coming to the C&I solution or scenario, right now Huawei is offering, or we previously used to offer as well, from 30 to 50 KTL inverters, which are the M3 family, and our biggest inverters previously, which were the 100 and the 115 KTL, and what we're going to talk about today, which is the biggest inverter in the C&I industry, the 150 KTL. But I always like to always clarify one thing. When we talk about biggest inverter in the CNI, meaning that the output voltage of the inverter is 400 volts. So do not compare to the utility scale, which are the inverters that have an output voltage of 800 volts. In addition to the PV inverters, we have also our energy storage systems, the Smart String ESS, starting from 97 kilowatt hour, 129, 161, and the biggest one is the 200 kilowatt hour, biggest one in the CNI scenario, along with the smart PV management system, which is the platform that allows you to control these components, monitor them, and as well, you get the alarms, notifications on it, and so on. So, what are the, let's say, value added dimensions that Huawei focuses on when it comes to its products? So, starting from the active safety to long term reliability, more power generation, which is an improved energy yield, and the simplified O&M. So, through the features that we're going to talk about today when it comes to this inverter, we're going to tackle each one of these value added dimensions. And of course, one thing that I also like to always emphasize on is that when we say smart O&M, there is a reason behind it. Because everything that we call smart usually kind of like, let's say, utilizes the experience when it comes to AI and big data technology and so on. And for that, it reduces the cost on the client. So simplified O&M reduces your time needed for the O&M, reduces the cost needed for this O&M, while also improving your energy yield. So automatically, the LCOE of your system will drop, making it more feasible for the clients to go for solar PV or as well PV with ESS. So let's have a look at the specifications of this inverter. So right now, the maximum efficiency of this inverter is 98.8 with a maximum input voltage of 1100, and it has 7 MPPTs, while each MPPT allows you to connect 3 strings, meaning that you have a 21 string in total. The maximum current per MPPT is 48 amps, and I would like you to pay attention to this number, the 48 amps, because it's going to be also mentioned in the coming slides, while also maximum short circuit current per MPPT is 66 amps. So the nominal AC active power is 150, but mind you, the maximum AC active power is 165. And I would also like to mention a point is that the D rating of this inverter in comparison to the inverters in the market have achieved a very, let's say, efficient or let's say good results when it comes to the degradation or the derating, because this inverter would allow you to produce an output power of 165 at 50 degrees Celsius. And Huawei always likes to be very honest with what we promise within our inverter. So we like to make it very clear what you can expect from this inverter. And also, as well, we don't overpromise. So that's also a number that needs to be taken into account when you are operating in this region. So when we talk about this derating values of the inverter, how were we able to achieve such low values for the derating? It's basically through the cooling method in Huawei's inverter, which is the smart air cooling, meaning that it has a smart self-cleaning fan. So if you'd look at this video right here, so what happens is that while the fan is operating in the operational periods of the inverter, if there is an accumulation of dust or soil on the blades of these fans, the fan automatically reverses the direction of its blades. So it kind of removes the accumulated dust without the need of manual cleaning and so on, which maintains high efficiency for the cooling process of the inverters while protecting also your inverters in running in high temperature ranges as well. And another thing that I would like to talk about when it comes to the specifications of this inverter is the weight of this inverter. Let me remove just this. So the weight of this inverter is 96 kilograms. And if you're familiar with our previous inverters, we used to have 2 strings per MPPT. But with this inverter, we raised it to three inputs per MPPT. Why did Huawei do that? It's basically to keep the inverter with low weight. Like, in a way, it will make the installation easier and the process simplified in that case. And a lot of concerns happen when it comes to how would you connect three MPPTs to, three strings to one MPPT if you don't have fuses. And we're going to come to that point also in the coming slides. All right. So some of these features, if we're going to compare the inverter to our previous biggest inverter, how did we upgrade these inverters? What are the improvements and the added features in that case? In comparison to the 115 KTL, the 150 has an improved maximum efficiency by 0.02%. And to a lot of people who are not very in depth into the solar industry, you think that that number is very low. But when you're talking about an inverter of a size of 150 kilowatt, so that means that this inverter would be used in larger scale of PV plants that are related to the C&I industry, larger rooftop installation, and so on. And any improved efficiency in that case, meaning that you have a higher revenue, so higher energy yield and better savings when it comes to the electricity cost. And another thing, in comparison to the previous inverter, previously we used to offer the installation resistance detection on a string level, on the equipment level. So for the MPPT. But with the new inverter, the inverter will be able to detect the insulation resistance up to the module level and mark the specific faults points in that case. But the thing is, and I also like to be very honest when it comes to these things, such features, if I mention anything during the presentation, talking about module level monitoring, module level installation, and so on, anything module level, meaning that there is an optimizer involved. And this new inverter is also compatible with the optimizers, and the previous inverters were not compatible with them. So another, let's say, added feature for this inverter is the SCLD, which is the Smart Connected Level Detector. And any of these features that I'm mentioning here, we're going to go into technical a deep dive on each one of them. Where are they needed? What is the added value or the benefit of these features? DC to ground protection is also another new feature added to this inverter. The PID recovery, which was present in our other inverters, but was not present in the 115, and now it's also in the 150 KTL. The total harmonic distortion, and this is an important point, because as you know, total harmonic distortion happens when there is, like, let's say, a deviation between the output waveform with the pure sinusoidal form. And this distortion causes, let's say, heating in the equipment, resonance, let's say, reduced power factor, and adds, let's say, an interference between, like, with the communication cables if they are running in parallel with the power lines. So there is a huge effect from the total harmonic distortion. And if you look at the inverters that are available for the C and I applications, usually they go less than 3%, less than 5%, and so on. But with a new inverter, we managed to achieve less than 1%, which matches our levels for the utility scale inverters as well. So that's comparing our inverter to our previously provided inverters. But if we look at the market right now, what are the inverters are available? There's also another suppliers that are also, they launched recently the 150 KTL inverter. If I did this webinar 2 months ago, I would tell you that we have the biggest inverter in the market, which is 150 KTL. But of course, working in this industry, you always have to keep up with the changes that are happening. And the suppliers need to also catch up with one another. So if we compare to these available inverters, more or less, if you look at this table, you'd see that there's a lot of things that are in common between these inverters. But there's two features that distinguish Huawei's inverter from the other inverters in the market, which is the main one, or let's say one of them, is the module level installation resistance. So in other inverters, this can be only achieved on a string level for the MPPT. But again, with Huawei, you can detect it up to, like, for example, string number 3, module number 4. There is an insulation resistance detection there. So you know exactly where the fault is happening. And the other one is DC to ground protection. And there's another thing that I would like to open your eyes to in a way. So when I come and tell you that these two inverters have same features, if I give you two phones, and of course both of these phones would allow you to make calls, both of them have cameras, but What is the quality of the pictures that you are taking with these phones? So when you compare the features, make sure to do it like apple to apple. So basically, what is the quality of these features and the specification of each of these features? And we're going to dig deeper as well into each one of these, and also the, let's say, level of precision and so on in the coming slides as well. So before going into depth in the safety features of this inverter, it's important that we understand the typical, let's say, DC faults that happen within the solar PV system. So we're going to be mentioning 8 types of DC faults, and basically we're going to tie the safety features to these DC faults. So it's important that you understand the causes of DC faults and the effect of them. So starting from the string current backfeed, which is basically happens when there is, like, let's say, an imbalance in the string sizes. For example, you have fewer modules connected in one string to the other, which causes a lower voltage on the terminals, and it causes a reverse flow or reverse polarity in these strings, which automatically would or eventually would damage your inverter if not reacted in a timely manner. So the other, let's say, type of DC fault, which is the risk of electric shocks due to high voltage of the modules. And this is very important for the safety of your technicians and the safety of your devices, let's say, in the system. So if you have a rooftop installation, for example, if the voltage on the terminals of the module are not is not equal to zero, then this would cause an electrocution risk for the technicians on site, and it might also cause a fire hazard. And in case the firefighters wanting to go on the site to extinguish this fire, they will not be able to for another safety risk on these firefighters. Another type of DC fault, which is basically the reduced insulation impedance, which is basically, let's say, it is the resistance to current leakage through the insulation of these cables. So if the cable breaks, let's say, this might cause a current leakage in the cabling or in the system, which might as well, let's say, compromise the safety of the other components as well. So arcing due to conductor breakage. I feel like I'm going too fast. I need to slow down a bit. So arcing due to a conductor breakage. This happens when there is two, let's say, conductors that their insulation is compromised in a way, and they are close to each other. So the voltage between these conductors breaks down the air. So it causes ionization in the air, and leading to arcing, let's say, or also sometimes the arcing can lead also to a fire hazard. The overtemperature due to loose connection of AC DC terminals. This happens because loose connections can create high resistance points, which can eventually generate excessive heat on these terminals when the current basically is flowing through them. Another type of DC fault, which is the reverse polarity, which happens basically if the positive and the negative connections are swapped. And mind you, inverters are usually built to operate on a specific direction for the current. So it handles the current in a specific direction. The inverter internal short circuit, which basically it happens when an unintended connection of, let's say, between a point, 2 points uh, in the inverter happens. So in the inverter's circuitry. So this causes a short circuit, an internal short circuit, and it's, of course, it leads to excessive current flow and overheating, and eventually the failure of the inverter. So let's come to the specifications of these safety features. The smart string level disconnection. You've heard of this feature before if you are familiar with our inverters. So this is also another feature, like this feature will also be present in our new inverters. And the smart string level disconnection is what I was talking about when I mentioned that the clients have a concern of connecting three strings to one MPPT. So the protection mechanism in this inverter will be through the smart string level disconnection. And we're going to talk about how this happens as well. The response time of this feature is 15 milliseconds. So it's an automatic, let's say, a DC switch tripping, and we're also going to talk about that further. The smart connector level detection. If there is an over temperature in the terminals, within half a second, the inverter will be reacting to that, sending you alarms and tripping the inverter. DC to ground protection, it's for an overcurrent protection. We're also going to talk about that. And the inverter should be able to respond to these faults within 15 milliseconds. If we're talking about an asset safety, which is the arc fault current interrupter, it's the only inverter that offers you a level 4 AFCI protection. And in our previous inverters, we used to detect up to a range of 200 meters, but we have improved it in this inverter to 400 meters. And the current detection level was previously 30 amps, but right now it's 48 amps. And that's why it's 48 amps, because of the maximum current per MPPT. So this allows the client to have more flexibility when it comes to the string sizing and also the designing of the system, while still maintaining the same precision, let's say, or safety requirements within the whole system as well. So coming to the smart string level disconnect and real-time monitoring. So basically, the SSLD will be able to detect up to 14 faults in the inverter, and it will automatically react to these faults by switching off or tripping the DC switch. So in traditional solutions, usually you have to manually switch off the DC switches or like turn them off and on. But with Huawei's inverter, it happens automatically. And mind you that the MPPTs are split into two DC switches in this specific inverter. So when we talked about 7 MPPTs, you have 3 MPPTs on one DC switch and then 4 on another DC switch. Why is this important? If you have one DC switch and there is a trip happening in the inverter, that means that you're going to lose the full power from the inverter. So losses on the energy yield, losses in the cost saving, and so on. But instead of losing the full power of the inverter, splitting it into multiple DC switches would allow you to just tackle the strings that have an issue with it within the MPPTs. So instead of losing 100%, you might be losing 40% or 50% of your energy yield, and while maintaining the operation of the inverter. So the inverter will be still operating, but these affected strings will be turned on in a way. So when we talked about the DC type faults, what are the DC type faults that are related to the SSLD? Talking about PV string, reverse polarity, input backflow, and internal short circuit in the inverter. And as I explained previously in the slide, the effect of each one of these and what is the cause of it as well. So coming to the string reverse connection, first of all, as mentioned, it's the swap between, let's say, the positive and the negative terminals on the inverter. The inverter automatically will be, let's say, tripping in that case. And if that does not happen within a timely manner, then the inverter will also, it will cause a failure in the inverter and might cause a damage as well in the inverter. So the main cause of this, as we mentioned, is also mentioned on the right side. And then the second part of let's say DC type faults that happen and the SSLD protects the inverter against it, which is DC input backfeed. And as I mentioned, if there is a difference between the modules connected to one string to the other, and since you have 3 strings and it kind of like increases the probability of that happening, if there is a reverse backfeed, then the SSLD will be triggered at once and it will be switched off, protecting the rest of the strings and protecting your inverter from further damage, and of course the internal bus short circuit of the inverter. So coming to the DC to ground protection. So basically, DC to ground fault is a low resistance between a DC point on the system and the ground. So the protection mechanism of the inverter is through installation resistance monitoring, ground fault detection and interruption, which we know in the industry as GFDI. And basically it detects the fault and then automatically interrupt the circuit of the inverter. So after that, there is the monitoring, also monitoring the residual current and automatic disconnection of the inverter, and then it sends you an alarm. What I want you to pay attention to as well is that inverters in the market are capable of withstanding an instantaneous current of 900 amps, but Huawei's inverter is capable of withstanding a level of up to 1600 amps. The inverter will not be damaged on these levels. And in case there was a detection of DC to ground, let's say, fault or compromise there, you will get an alarm on the notification or on the portal that there is a low insulation resistance. And if you see on the right side, you will get also the alarm causes. What are the causes of this alarm? And also how to fix this issue, and what are the suggestions to overcome these causes as well. So the real-time connector level detection. So basically, and one thing like I've been reading about in some of the articles, there were a lot of projects, specifically the one that I was reading about was in South America. So there was a project that there was a cause for overheating in the terminals of the inverter, and it caused the terminals to melt in the inverter. And if you're familiar with the with our inverters, some of the inverters in the market, if the terminals of the inverter are damaged from melting, overheating, and so this would require the client to change the full inverter. So you cannot just change the terminals of these inverters. And this causes a lot of losses in the PV industry from that cause. So what Huawei has done to overcome this issue is by installing NTC thermistors, which is basically the negative temperature coefficient thermistors on the terminal board of the inverter. So these, let's say, NTC points, basically the let's say the operating mechanism of it is that when the temperature increases, the resistance and then decreases. So while the resistance is decreasing, the inverter will be able to measure the temperature of these terminals, and if it goes up to 65 degrees Celsius, then the inverter will automatically trip, and then it will protect it from overheating any further and melting these inverters. The response time for this let's say operation is happening within half a second. The inverter will shut down to protect all of the components and also prevent it from let's say evolving into a fire and so on. If you look at the temperature detection points, they're on the negative and positive let's say terminals of the PV strings as well, connected to the inverter on the AC side. Coming to the AFCI, so basically this level 4 that we talked about, and previously I have explained it. So why is it important to have, let's say, higher levels of detection or higher current levels of detection? Because usually for the arc fault, what happens is that the arc characteristics signal is weakened with larger or longer cable ranges, and is also weakened by the increases in the current levels as well, which causes a lot of noises in the signal. So it kind of as well compromises the precision and also the time response of these faults happening. So that's why Huawei has been working on improving the precision of detecting these DC arc faults happening within the system. Because if you think about it, or if you know, basically DC arcs are way more dangerous than AC arcs, because the main reason is behind having a DC current. It's a constant, a consistent one. So the current is flowing at all times in comparison to the AC currents, the alternating current in that case, which makes it on the DC side very hard to extinguish these fires or as well put them down. So coming to the intelligent reactive power compensation, which is basically the reactive power compensation in the inverters. Basically, it generates or absorb reactive power to help maintain the voltage levels on the grid. So this is crucial, basically, because it can affect the voltage profile of the distribution network. And through our inverters, there is an automatic adjustment that happens through monitoring the grid voltage and the reactive power levels, and also advanced, let's say, control algorithms that allows the inverter to fine tune the reactive power output and with high precision. So there's a lot of concern when it comes to this point in the industry, because a lot of people are, let's say, concerned about compromising the energy yield from the inverters, because of course, if you're generating or absorbing more reactive power, you're also compromising, let's say, the usable capacity or the usable energy yield from the PV inverters. But with this dynamic closed loop control and within 10 seconds response time, the inverter will be adjusting its reactive power levels in that case, protecting the components, protecting the grid, while also not losing a lot of power in that case. So coming to another issue. So previously, in the previous slide, if you have noticed, we've been talking about more or less on an inverter level protection, and we're talking about the strings and so on. So coming to the issues that we face with the module itself, and PID is one of the biggest issues when it comes to the performance of the solar PV system. PID stands for the potential induced degradation. And what is the cause of this potential induced degradation? Is basically voltage difference between the components of the solar module, or an accumulation of charge on these solar modules, or for example, the ionization and so on, and the current leakage in the through the glass or encapsulant of the module itself. And in a lot of cases, this causes a huge loss in the energy yield of the PV system, and compromises the performance of the PV system and the PV modules. And if you look at our regions, and I'm talking about GCC mostly and the Middle East, we have a region that is known for high temperatures and high humidity. So these are the two, let's say, environmental conditions that drives the PID effect further. So basically, with high humidity, you have the moisture penetrating the glass, and also, let's say, providing a connecting path for the current inside of the module. So current leakage, and also the temperature, which accelerate the degradation of the insulation material inside of the module. So which makes it more probable, or increases the probability of the PID effect on these inverters. So Huawei's inverter has a PID recovery, let's say, functionality in it, which basically is that within the non-operational periods of the inverter will be applying a reverse bias voltage to kind of counter effect the accumulation of these charges on the module, or even specifically the negative potential on these modules, which protects the performance of your PV modules, and also improves the energy yield. And we have a case where we have tested that using PID recovery and without using the PID recovery in China. So it was a rooftop installation, and Huawei has noticed an improvement in energy yield by 3%. Again, sometimes we look at these numbers and we think that it's a small number, but if you work in EPC companies and operators and so, sometimes you have penalties in your contracts in order to achieve a specific performance ratio or an energy yield from the system. So you cannot go below that. So any additional percentage in the energy yield, while also maintaining the same capex that you are investing in the system, would mean a lower SOE and would add another value to the system. So another thing when we talk about the module level, so we talked about the PID effect of the module, and then now we're going to talk about the monitoring of, or let's say, the predictive maintenance of the module. So the module level installation detection, and this is, mind you, a reminder that this is a unique feature in Huawei's inverters, which is not available in the market. Again, the market has it on a string level. So the module level installation detection basically is that it kind of like monitors or measures the resistance levels between the modules and the ground. And then the inverter, instead of just giving you that there is a string, there's a compromise in the installation on a string level, it will take you to the module level. And giving this specific point of failure, this will reduces a lot of time when it comes to the O&M of the system, and will reduce the cost as well. And if you look at these graphs, instead of having, okay, this string has an issue, you will have this module has an issue. So basically, specifically locating that fault. And instead of like scanning the full PV array, you just go to that module and analyze the issue happening there and fixing it, and so on. So RSD, which is basically the rapid shutdown device. And if you remember from the DC type faults, we talked about two main things when it comes to the RSD, which is basically the, let's say, the hazard of electrocution on the firefighters. And if, in case of an O&M as well, the operators or the technicians would not be able to, let's say, inspect these modules. So what happens basically is that even if you turn off the inverter, there will still be a residual voltage on the terminals of the modules. And if the sun is still shining, then your module is still giving an output power. Your inverter is not seeing it. So if you touch these modules, and basically we're talking about high voltage levels of 500 to 1000 on a DC level. So this causes a huge risk on the technicians, and also a further, let's say, evolvement, or let's say evolvement, let's call it evolvement, in the fire hazard in that case. But with the rapid shutdown, which basically also happens using optimizers. So let's be realistic. We're talking about module level. There is going to be an optimizer, and usually with Huawei, we usually say that you can, let's say, install or deploy optimizers partially on your system, which is another added value to our optimizers. But when we talk about the rapid shutdown or the monitoring on a module level, then you need to have optimizers on all of your modules connected to the inverter in order to achieve these features. And once the inverter is turned off, then your optimizer will make sure that the voltage levels on the terminals of the module is also up to zero, around 0 volts. So which adds another layer of safety and protection for the system as well. So we talked about, let's say, the specifications, the added values of the inverter from a safety perspective, and improved energy yield, monitoring, and so on. But there's another part of the LCE that we talk about, right? Which is the capex of the system. So if we're going to compare a system of 1 megawatt, let's say, using the previous 110 kilowatt inverters with the 150 kilowatt, so you're going to be reducing your BOS, which is the balance of system, by almost, if not even more than 0.06 cents per watt. So in that case, why is that happening? First of all, and very obvious reason, is basically because you're using less inverters in that case. Less inverters, meaning that you're also using less AC cables for the connection. And in that case as well, since you have also three strings, and improving, or let's say increasing the current, the maximum current per MPPT, allows you to also connect more modules in series to one MPPT. So that's lowering your cost even more. And we're also improving the energy yield by an increased efficiency of these inverters. So please, when you analyze a solar system, and this is an issue within our region, is that we always focus on the capex of the system. What is my initial cost of the system? Okay, so we have improved the capex in this case. We made it less, or let's say lower, with using bigger inverters. But there is also the other part to it, which is the OpEx. What is your operating cost of the system? When you talk about solar PV systems, we're talking about an operating time of period of 15 years, 20 years, and 25 years, which is the lifespan of the inverters, let's say. So in that case, you're accumulating, let's say, OpEx cost is very high throughout the years. So if you can also reduce that part, so wouldn't you also focus on that? Why do we always focus on the present time of the initial investment of the solar PV? But also keep in mind your operating time of these systems as well. Which brings me to the point, the smart O&M cost. So when it comes to anything that is run by humans, or let's say a manual inspection and so on, there's also a high percentage for error. We're humans after all. But while integrating AI into the mix, let's say, so the auto detection and automatic response and monitoring of the system will not only improve your precision, but will also reduce your need of sending these technicians on site, which reduces the time needed for the inspection and reduces the cost in that case, while also maintaining the high precision in that case. So when it comes to our systems, if you're using Fusion Solar Smart PV management system, you're also detecting the monitoring the system as a whole, and there's also another added value there. So we have introduced the smart design tool for our inverters. Of course, if you're going to use it, if it's a free of charge, but it kind of obligates you to use Huawei's inverters in that case, and it helps you let's say, do the electrical configuration of the system. And it's kind of similar to Helioscope and SketchUp. So if you have a shot from Google Maps, it kind of shows you how many modules you can put on this roof, what is the optimal electrical configuration, the inverters needed in that case, and the difference between using optimizers and not. Yeah, so it's kind of very useful for the preliminary design of the system. So to summarize everything that, not everything, but most of the things that we have been discussing in the webinar, let's just have a look at this video that summarizes all the, let's say, features of the inverter and added value. So basically, more or less, these are the main points that I wanted to cover within the webinar. And to be honest, I would have loved to go into more technical depth into that, but also time restraints as well. But the thing is that I would also like to point out in this webinar is that Huawei is trying its best to be able to cover an integrated solution when it comes to solar PV and ESS. So one thing that you've seen in the video is a one-stop solution. So we're trying to cover all of these components, and you would get the components from Huawei, from the optimizers to the inverters to the ESS to the monitoring platform and so on, and even on a utility scale, the smart transformer stations and so on, and the communication platforms and so. Maybe at the moment, the only thing that we are not providing is the PV modules and the cabling as well. But let's see what the future is holding for us. If you have any question, I'm not sure if I can see the chat, but if you have any question, just maybe send it to Solar Quarter. And as well, this is my email. You can contact me at any time, send me your questions, or if you would like a further explanation and so on, please feel free to contact me. I'd be more than happy to answer your questions.
Thank you so much, Mr. Harbi, for sharing such an insightful masterclass on the Huawei inverter, Sun 150K inverter. And we do have a few questions that have been posted by the audience here, and we do have some time with us. So I'll just screen a few here on the stage. So it
Yeah,
says,
Yeah, so it was mentioned in the slides. So basically, in comparison to the previous inverter, which is the 100 KTL, first of all, the 100 KTL, one of the features it had was the AFCI, which is also present in the 150, but the detection range and the current was improved in the 150. And there's another thing, the smart connector level detection, which was not available in the previous 100 KTL inverter. In the new 150, it can detect the temperature levels of the terminals of the inverter and the connectors. In the previous inverter, we used to do the insulation level on a string level. So basically, you can also only detect up to the MPPT and the strings within the MPPT. But with the new inverter, you can also detect up to the module level. So these are some of the, let's say, added values in the new inverter. And as well, the efficiency of the new inverter was improved and increased to 98.8 percent in comparison to the 98.6 from the 100 KTL inverters as well.
we have another question here.
So, very good question. So, one of the things I think I've mentioned it in the presentation. So, an increase in the temperature of the inverter would definitely cause it to shut down. And as well, for example, if there is an insulation in different strings and connected to multiple MPTs to the DC switches, if both of them are triggered, it's going to shut down the inverter. And more or less, what we talked about that is connected to the SSLD, which is basically if it's If it's on a string level, the reverse backfeeding or let's say reverse polarity, these are only tied to the DC switch for the MPPT with the strings connected to this MPPT. So there are a couple of faults that would cause your inverter to completely shut down, but we try our best to reduce these faults in order for you not to face these issues. So for the inverter to keep on operating while isolating the strings that have an issue with it. So yeah, I would say like two or three of these faults would cause your inverter to shut down completely. To Oh, yes, of course. So basically, if you are using our smart logger, there is a feature in it which is the zero export feature. So it limits, let's say, any export from the inverter or the PV system back to the grid. You can set it up, and there is a user manual for the smart logger, and it can be easily done. And we have deployed it in many countries since there is also a regulation in some of the countries in the GCC. There should be a zero export back into your grid. So that is possible. So right now, of course, it's dependent on the module that you are using, and of course the size of it, the type of it, and the specifications of each module. But we can achieve up to 22 modules in series for the big modules in the market, 210. But this question is a bit tricky because we need to understand as well which PV panel you're using. What is the specification of this panel? I might tell you now 22, and then you'd come back to me like you said 22, but your panel has a different, let's say, VOC to it. So specific to the panel. But I'd say like 21 to 22 in series. And I don't know if I understood the question correctly, but like, what's our policy to upgrading the inverters that are already inside on site? Did I understand that correctly? If you can help me, Ahla.
I believe so. They basically want to know if they've already purchased the inverters, how can we upgrade them?
Well, I would love to tell you that we're going to replace all inverters in the market, but the thing is, if the inverter is already installed, then it's there already operating. But the client is always welcome to purchase the new inverters and replace the existing inverter, but at your own cost, of course.
And one last question we have here. uh,
You need the smart logger for that. It is needed.
Okay.
Are there any other
We have
questions?
one more question. So people have just raring to know more about this inverter. So I'll
We
just
love
screen
that.
one last one.
Start derating on. So a very good question. So basically on 30 degrees and 40 degrees, the inverter would still give 165, but at 50 degrees, it goes to 156. So after that, it starts derating, but still, let's say like the derating it would reach at like 60 degrees, it would be like around 147, 150. But for these values, we can send you the characteristics curve, and you can also do your design based on it. But if we're talking about this region, then we're talking about the 50 degrees Celsius because that's the temperature that is maximum here in a way. And for that, you're going to reach 156 kilowatts of power output for the inverter. I see a question, someone asking if it's available on UAE market. It is
Yes.
available. It is available. Sorry, I just got that on the chat. It is available, yes, but um, we're getting the approval from DIWA while we're speaking right now. So we're getting the approval, and yes, 100%, and it can be grid connected as well. How does increasing the increase the number of series of all the journeys to that? No, we're talking about basically for the current was for the AFCI. This is what has been mentioned. So the AFCI capabilities of detecting the range because the current levels that we have improved here basically is for the signal, let's say the noise in the signal for the AFCI. That's why I mentioned the number of modules or the current if that's what you're talking about in that case.
So, Mr. Hobby, we have one. I believe this is the last one now. So, I'm screening the last question here now. People are really thoroughly enjoying your interacting with you here.
Amortization. If the client is buying new inverter to replace the old one. Ah, I would love to answer this question, but the thing is, I'm responsible for the technical side. This part would be with our commercial team. So, if I'm pronouncing the name correctly, Mercia, please feel free to send me an email and we can look into that. And I can also respond to this question after discussing with our commercial team.
Okay, we've just received one more. Mr. Habib, do you think you have time to address one more question?
Yeah, of course.
Yeah.
Can you provide a device which can connect with Huawei inverter? Yes, so basically that happens when you install the power meters. We have the DTSU 666 power meters as well, the smart meters that are connected to also the grid, and they analyze the power from the grid into the grid. So in that case, using that would allow you to see the import and export to your grid. We can also send you the data sheets and user manuals if you send me an email.
So that's about it for our questions for today. And I would like to thank Ms. Sahabi for her exceptional presentation and masterclass, as is evident from the outpour of comments and questions here. And as we conclude here, I would just like to extend my appreciation to Huawei for their unwavering support in organizing this event. And thank you to all our audience for engaging in this session. And we will be back with more sessions like these. Thank you once again for your participation.
Thank you so much, Ahla. Thank you everyone for attending.